morning, good afternoon. It is Wednesday, December 1st. Happy Christmas season, everyone. Ho, 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 and mistletoe and all those wonderful things, right? So we're going to get started today by talking about our review slide. That's going to be our first step, as always. What I have noticed is that everyone seems to be doing okay with number one. We seem to have our wits about us with this top part here because we know that these parts don't change. That stays like that because they're always cut into the same amount of parts, equal parts. The denominator stays the same. So if we have 12/5 and we want to take away 1/5, we can deduce that how many are we going to have left, everyone? 11/5. So 12/5 minus 1/5 is going to equal 11/5. The way we would put this on our number line is we would count 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11,
12. We're stopping at 12 because that's our number. And then we're subtracting, so we're jumping back 1/5. And when we do that, we land right here, which is 11/5. We're all doing pretty good with this part here. Understanding that if I have 12/5 and I jump back one, that would be 11/5. I think maybe every single person in the room got that right. Yeah. Every person that tried got that correct. This is where the wheels start to fall off the cart. This is where we start to have real trouble. Okay? Here is what you have to know. I'm going to draw a red box around this first number. This first number is a mixed number. It's called a mixed number. It's a whole number and a fraction put together. That's like saying I have 2 Reese's and then a little extra. I've got 2 Reese's and then I have 1/5 of a Reese. So I got 2 and 1/5. That's what that means. So if we want to plot this on the number line, we know that this denominator tells us the pieces that it's cut into. So if we have 2 whole things, 1, 2, 3, 4, 5. There's 1. 1, 2, 3, 4, 5. That would be 2. But we don't only just have 2. We have 2 and 1/5. So our dot is going to land right here. That's the eraser. Our dot's going to land right here. 2 and 1/5. Okay? That's how we would plot this on the number line. Let me erase this other 2 here just to eliminate any confusion. We would put that on the number line right there. Now, it's telling us to subtract again. How much is it telling us to subtract, Dominic? 4/5. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. We're going to subtract 4/5, and we're going to land right here. When we do that, what's left on our number line? We have 1 whole thing, and how much? 1 whole thing and 1 and 2/5. That's right. Now, a common answer I saw today was this. And this has been all day, not just in this class. This has been all day. 2 and 1/5 minus 4/5 equals 2 and 3/5. So let's talk about that for a second. Look at me. When you're not looking at me, it makes me feel like you're not really with me. If we have 2 and 1/5 Reese cups, think about Reese cups. I've got 2 Reese cups and then a part of 1, right? Each one of these is cut into 5 pieces, right? So here's the 2 holes cut into 5 pieces, and here's the 1 little piece. 2 and 1/5. If I take away 4/5, does it make sense for me to land for me to end up with 2 3/5? Which is bigger, 2 1/5 or 2 3/5? 2 3/5. So if I start with 2 1/5 and I take away 4/5, does it make sense that I would have more than I started with? No, because it's subtraction. We're taking away. Let me show you what your brain's doing. Your brain sees this 4 and this 1 and is like, oh, 4 minus 1 is 3. Boom, done and done. No, not done and done. That does not work. So
They didn't pay attention to like if there was a like a big whole number.
yes, that's correct.
So
let's talk about this 2 1/5. Let's use this picture. Let's talk about 2 1/5 with this picture. If I have 2 holes and each hole is cut into 5 pieces, each hole is cut into 5 pieces, and then I have 1/5 here. How many fifths do I have in that picture right there? Dominic?
10.
Well, I've got 5 here and 5 here. That's 10. 11 fifths. I have 11 fifths. So this is 2 1/5, right? So 2 1/5 is the same as 11 fifths when you draw it out like that. Now you can subtract. 11 fifths minus 4 fifths equals what, everyone?
7.
7 fifths. And we know that's true because we have fifths on this number line. 1, 2, 3, 4, 5, 6, 7 lands in the same spot as the 1 and 2 fifths. Right? So your answer could have been either one of these two things. 7 fifths or 1 and 2 fifths. Okay? We're going to talk more about this today, a lot more. We're going to talk a lot more about this. Okay. The numbers in subtraction. We are still talking about subtracting fractions. Let's subtract fractions from whole numbers, shall we?
Yes, we shall.
Woo! Here we go. Oh, it's my favorite, a number talk. Are you ready?
Yes.
Here we go. When you have your answer, nose goes. You don't have your answer yet. You haven't even seen it. Oh, some of you already see it on there.
Yeah.
Go. Nose goes when you have your answer. Before we announce, nose goes for your answer. Before we announce our answer, can you read this to me? What does it say? Read it out loud, everyone.
2 roots of 3, 12.
Thank you. And the answer is, everyone?
6, 12.
Yeah, very good. So if I have a group of 3/12 here and a group of 3/12 here, and I put them together, 3/12 and 3/12 makes 6/12. Very good. You ready for your next one?
Yep.
Nose goes when you have your answer. Everybody say it together.
18, 12.
Very good.
Or
No, not or. Don't say the mixed number. Just leave it how it is. 18 12. Ready for the next one?
Yeah.
Here we go. Whoa.
Oh gosh.
That's hard. Everybody say it together.
36, 12.
Good job.
That is so far.
And the hardest one yet. Remember, on a number talk, you use the answers you've already mentioned to get the answer you're looking for. Nose goes when you got your answer.
I like how as soon as I see it, I just put my nose on. Or let's speak it here.
Jackson Pringle, what do you got? 360 12. How'd you get that, Jackson?
Because I thought that if there was 12 times 3, and you could just then you could keep a 0 because that since it would be 12 times
You're right. He's saying, I knew 12 times 3 was 36, so I just covered up that 0 for a second. 12 times 3, and then I put the 0 back. We've talked about that. We've talked about this before. What's 12 times 2, everyone?
124.
12 times 2. 12 groups of 2 is 24. So 12 times 2 is 24.
240.
240.
Oh,
Gabe?
it is 2,400.
That's right. We could go on and on. However many zeros. Look, 12 times 2 is 24. 12 times 20. Cover up that 0. Do your 24. Put that 0 back. That's all you have to do there, okay? That's all you have to do there.
And it would be the
Okay.
same with 1 million and 1 billion.
What do you notice? What do you wonder? 30 seconds of think time, and then you share with your table. Go. Thinking silently. What do you notice? What do you wonder? All right, talk to your table. What do you got, Emma? What do you notice?
I noticed if you can put the 3 cups into a function.
Okay, somebody from table 3. Trenton?
I noticed that it's only filled up to the 3 mark. Let's do the 4.
Oh, sorry. Filled up to the 3 mark. Table 2, Landon?
I noticed that
What?
I forgot.
Annabelle?
I wonder if we're going to subtract something away from the 3/4.
Bobby?
I wonder if it's actually like 3 cups because it doesn't have cups under it.
Gabe?
I've got a notice and a wonder. Okay, so I noticed that it's actually showing 3/3. Well, more of 9/3 actually.
Not thirds. 1, 2, 3, 4.
So 3 holes of a 4.
Okay.
And
When
why did they have to make it like a pinkish reddish, purplish color?
Remington?
Just darn it.
Izzy?
I wonder later in the story if we're gonna add to it and make it 4/4. I got it back.
Did I talk to somebody from every table?
I think
Yeah? Okay, that was the goal. So 1 person from every table. All right, so can we make the 3 into a fraction? We notice it's filled to the 3 mark and that it's cut into 4ths. Please hold your pencil still. Wonder if we're going to subtract something, 3 cups, and why is it pink? Are we going to add to it? Okay. Here we have some information. A pitcher contains 3 cups of watermelon juice. Ugh.
Ew.
Why would you need 3 watermelon juice?
Popsicles.
Ugh.
Popsicle.
Oh yeah, watermelon flavored
Okay.
popsicle.
How many cups will be left in the pitcher if we pour each of the following amounts from the full amount? So, what is the full amount? How many cups do we have in the full amount? 3 cups. We have 3 full cups. We're going to take away 1/4 of that. How much will be left? I want you to put your hands down. I want you to take some think time to look at the picture closely on your screen and think about that expression, that equation. 3 minus 1/4. If I have 3 cups, open your computer so you can look at your screen. What are we doing here? If I have 3 cups and I take away 1/4, how much juice is going to be left in that pitcher? Now talk to your table.
Yeah,
everything is 1, 2, 3. That's just the that's like the
Are you ready to share your answer? All right, table 1. What do you got? What was your answer, table 1? What did you say your answer was?
Oh, 2/3.
2/3. Table 2.
We said 2 3/4.
2 3/4. Table 3. Table 3. Table 3.
Well, we really didn't get to decide on an answer,
Okay, we don't have an answer
No,
at table 3. Table 4.
which I'm saying, well,
2 3/4.
Huh?
2
2
3/4.
3/4. Table 5. 2 3/4. Table 6. 2 3/4. Okay. So let's talk about this now. We're starting at the 3. We're taking away 1/4. And now we're looking and seeing what we have left. So we have this hole here. That's one hole. There's a second hole, and we have 1, 2, 3 left. 2 3/4. That is correct. 2 3/4 was the correct answer. Now, talk to your table about the next one. 3 minus 5/4. Yes, you're right. He's right. Listen to him. He's saying, why are you saying that? What does that So he's right. Somebody explain why he's right.
So it was 1 That's why I put my trust in you.
Class?
Yes.
Ready to share?
Yes.
Logan, what'd you get for table 6?
So 5/4 minus 3 holes equals
Please hold the pencils still.
1 hole.
1 hole and 3/4, right? Yep. Table 5?
I got it.
Table 5?
1 3/4.
1 3/4. Table 4?
1 1/4.
1 1/4. Table 3?
was 1 3/4.
1 3/4. Table 2.
1 3/4.
Table 1.
1 3/4.
All right, so we have a lot of similar answers again with one difference. So let's show this let's show this. We have our 3, we're starting here, right? How much are we going to count down? 5/4. So 1, 2, 3, 4, 5. Talk to your table about whether or not you guys were right. If you were right, prove it. If you weren't right, fix it.
So now let's try. Hey guys, I know it's going to be on one score right. 1 minus 1. It's like 3/4. And 2 whole numbers. 2 3 We were right. We were right. Hey guys. I know. I didn't make your high five. Is this okay?
I think he needs like number 6.
I know that it's number C. Oh, okay. I did this. So, one yeah, I know.
Class.
Yes.
Did you figure out whether you were right or wrong?
Yes.
Okay. Now let's talk about the last 2 as a class just for purposes of time, okay? Okay. Our answer was 1 3/4. That was correct. All right, now let's take 3 minus 1 1/4.
Oh, that's
3 minus 1 1/4.
I like how it's
Do this with your table again. Do this with your table again, real quick.
Yeah. So 1/4 minus 3 whole. That'll be like 1. So yeah, 1 whole is 1 and 3 whole.
I said that. I knew it.
Anybody noticing anything interesting?
Wiki.
What's interesting, Trenton?
It's that you get rid of 1 1/4 and you get left with 1 1/4. So 1 3/4.
Yeah.
1. Would you say this is 1?
Yes.
You mean to take away that 1? That leaves us with 2 holes, correct?
Yes.
And then how much do I still need to get rid of?
1.
The 1/4? So then how much do I have left?
1 3/4.
1. What? And 3/4. And 3/4.
I was like, wait. I thought
What's
we were
interesting
done.
about that? Why is that interesting, Tucker?
I saw something else about that's not about the product. Well, the answer. Can I go up there and show you?
Just tell me. Quickly.
The number one, one whole and 1/4 is almost the same as the top one, except take away the 1.
Similar to this? Yeah, sure. What about these two things in yellow?
It's basically the exact. That's actually the exact same thing, only saying it differently.
Who else noticed what Logan is saying is that these two things
I'm
in
not
yellow.
I'm not Logan.
You're not Logan. You're Gabe. I'm so sorry. I apologize. I know who you are. This is a mixed number, and this is an improper fraction.
I literally did this question while I was doing the
What were you
top
saying,
one.
Jackson?
I was gonna say that there, but that the top one was improper.
Oh, this one's improper, and this one is mixed number. Right. All right, 3 minus 2 and 2/4. 30-second think time. We've done these. You're thinking silently first, and then you're working with your table. We've been doing these together. We should be able to figure this out. Oh, let me erase the picture. Whoops, sorry.
How this one is literally just 1/4.
Talk to your table.
Okay, so no, I know. And where do you go?
Class?
Yes.
What did we come up with? Does somebody have an answer? Someone have an answer? Annabelle? 2/4. Who else thought it was 2/4? Okay. We start at the 3. We're going to take away 2 holes, right? 1 hole. Another hole. 1, 2. Then we have 1/4 here. 1/4 here. That leaves us with 2/4. Does anybody know what 2/4 is the same as? Is he?
1/2.
1/2. Very good. That was just extra. Very good.
It's the exact same.
Now, if we have a second pitcher that contains 4 cups of water, how many cups will be left if we pour each of the following amounts from the full amount? So I want you to do this in your cactus notebook. Oh, it's not 3. Now we're changing it up a little bit. We have 4 total cups minus 1/3. 4 total cups minus 5/3. 4 total cups minus 2 and 2/3. I want to come around and check on your reviews, or not your review slide. I want to see what you have to think about this in your notebook. Not on a new page, on the same page from today. Today already has a page. Draw it up if you need to. Draw your little picture if you need to. All right, let's talk about this together. I'm walking around. I'm not seeing very many right answers. So I'm going to draw 4 over here. 1, 2, 3, 4. We have four whole things. Is that correct? Yes. Each of these whole things is cut into how many pieces? 3. That's right. How do we know that? Because our denominator is a 3.
Makes a letter called a Y.
No, that's 3 pieces. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So 4, if we take away 1/3, how many whole things do we have left? How many whole things do you see here?
3.
3. And how many? So that's these. How many thirds do we have left?
2.
2/3 are left. That's one way you can figure this out. Draw 4 whole things, cut them into however many pieces your denominator tells you to, and then X out what they're asking you to X out. Now we're going to use the same diagram because we're still starting out with 4 holes. So we're going to use the same diagram. What am I going to cross out? Jaden? 5/3. 1/3, 2/3, 3/3, 4/3, 5/3. How many whole things do I have left? Jaden? Okay. Jaden counted the thirds that are left. 1, 2, 3, 4, 5, 6, 7. Are you allowed to do that? Yeah. What if I wanted to write it as a mixed number? Izzy?
It's gonna be 2 1/3.
2 1/3 is correct. 2 1/3 is correct. Let me erase our marks here. And finally, 4 minus 2 2/3. What are we going to cross out now, Bobby?
We're going to take away the 2 top ones.
We're going to take these whole entire things away, aren't we? Because it's telling us to take away 2. So here's 1, 2. We're getting rid of that whole thing. And then what?
Then we'll take away 2 of those.
2 of the thirds?
Yeah. Then it'll be 1 of 1/3.
1 1/3. If we wanted to write it as an improper fraction, it would be 1, 2, 3, 4/3. You can do that either way. Subtracting fractions from whole numbers. Today we learned that we can subtract a fraction from a whole number by either rewriting the whole number as a fraction or by decomposing the whole number. Are there any other words or phrases that are important to include? Oh, that was from the other thing. That was from something else. All right, so this is what I'm going to have in your review slide for tomorrow. So I want you to be thinking about taking whole numbers and subtracting fractions from them. How do we do that? Before we go, let me talk to you about one more thing. Four minus 1/3. Okay, I'm going to use that one. 4 minus 1/3. Before we go, I want to talk about this one thing. We had 3 or 4 circles drawn, right? And they were all cut into 3 pieces each,
Yep.
correct?
Yep.
Of these 4, how many thirds? If I have 4 holes and each whole thing is cut into thirds, how many thirds am I going to have? Please don't pack yet. Dominic? I have 4 whole things. Each thing is cut into 3 pieces. How many pieces do I have? How many pieces do I have, Tucker?
12.
12. So 4 is the same as 12 what? 12 thirds. 12 thirds minus 1/3 equals 11 thirds. So you can always turn your whole number into an improper fraction if you wanted to. You don't have to, but you could. All right, that concludes our math lesson today. We're off. Bye, guys.
Peace, everyone.
See you tomorrow.
Bye.
Bye.